Okay everyone, today we are focusing on lesson 11 in your notes packet on efficacy of scientific notation. So this is just going to be a quick little lesson just to touch base, giving you a little more practice with word problems since you are able to use your calculator on the test. So let's get started. So what I would like you to do is try to do exercise 1 and exercise 2 on your own. All it's asking you to do is write them both in scientific notation, because the mass of the proton is that very huge number, mass of electron is this very huge number. So try to do it on your own, try to do it without the calculator, and then double check it in the calculator. And pause the video and then press play when you are ready to check your answers. So for the first exercise, you should have gotten 1.6272622 times 10 to the negative 27th kilogram. Make sure to label, and the mass of the electron is listed below. Make sure your calculator was in the SCI mode. If you are still not getting these answers correct, now is the time to ask your teacher, because you don't want to miss points on the easy questions on your exam. So, for exercise 3, it says write the ratio that compares the mass of the proton to the mass of the electron. So for this problem, we're just comparing the mass of the proton to the mass of the electron. Now, when you're doing this, would you rather write these very long numbers that are in standard notation, or would you rather write them in scientific notation? Oops, there goes the bell. I apologize about that. If it were me, I would rather do them in scientific notation because it's a simplified form. It doesn't take as long. And actually, I'm even going to round both of these to the nearest tenth at the moment. So if it were me for the first one, so for the mass of the proton from exercise 1, I'm going to say roughly 1.7 times 10 to the negative 27th. The mass of the electron, I'm going to round to 9.1 times 10 to the negative 31st. So all there you had to do for exercise 3, write them as a ratio when you're comparing two values. Like I said, scientific notation is a more simplified form, so you don't have to write out the very large or very small values. It's just all given to you as a power of 10, and it's also an easier way to compare them. Okay, so for exercise 4, I need to compute how many times heavier a proton is than an electron, and it's telling you find the value of the ratio. So all you're going to do is divide them. So I'm going to take my proton and divide it by my electron. So my proton was roughly in scientific notation 1.7 times 10 to the negative 27th, and my mass of the electron was 9.1 times 10 to the negative 31st. So in your calculator you will divide these. The only thing you have to make sure to do is to put parentheses around each value. Make sure you do that. When you do that in your calculator, you would roughly get 1.868131868 times 10 to the third power. However, this question says round your final answer to the nearest one. So that is making you change it back to your normal mode. So make sure you go to the mode and hit norm. You could also clear out your memory, and that will always resort you back to the normal mode as well. So if you do that in your calculator, you get the standard notation. You would roughly get 1,868.131868, but it just says to round to the nearest ones place, so your final answer would be 1,868. So like I said, here's your answer in scientific notation, here's your answer in standard notation rounded to the nearest one. In example 2, they're basically doing all of the work for you. It says what is each citizen's approximation share of the debt? Well, in your numerator, it's giving you the total U.S. debt. and in the denominator it's giving the total citizens. So of course you are going to divide to find the approximate share of each citizen's debt. So basically in your calculator, you don't have to worry about any of this business. In your calculator, you would just do what is over here. Make sure you're putting what's in your numerator in parentheses and denominator in parentheses. When I do that in my calculator, I would get roughly 53,359.87 cents. But if I wanted to round to the nearest whole dollar, you would get roughly 53,360. Like I said, the key is putting it into your calculator correctly. Also, they converted this value and that value into scientific notation and then divided. Why don't you try to do exercise 5 and 6 on your own, and when you are finished, press play to check your answers. So for exercise 5, you should have taken the area of the U.S., which is here, written in scientific notation, which they gave you, and divided it by my area of California, which roughly gave me 2.3. Yes, I just rounded this value, so I didn't write everything out, times 10 to the first power. But the question said, then compute the answer to the nearest 1. So that just means round to the nearest ones place, which would be roughly 23 Californias for your final answer. Remember, if you are not getting these, please ask your teacher for help. For exercise 6, excuse me, you were just taking your distance from Earth to Mars and subtracting it from your distance from the Earth to the Moon, because I want to know how much farther Earth to Mars was than Earth to the Moon. If I subtract these values, I would get 9.2016 times 10 to the 7th. That's the scientific notation mode. But if you wanted to get your standard answer, which remember is your norm mode, you would get 92,016,000. Right now, I want you to go to the problem set. I want you to ignore questions 3 and 4. Instead, I would like you to try question 1 and 2 on your own. Pause the video and then press play when you are ready to check your answers. So for number 1, your answer should be there are more atoms in the average human body, because you must look at your exponents. 27 is larger than 18. So always to compare, look at your exponents to see which are larger or which are smaller, depending on what the question is asking you to do. And for question number 2, I'm going to write down here below just to give me more room. It says about how many times more atoms are in a human body compared to grains of sand on Earth. When it asks, anytime it says about how many times or how many times larger, you are always going to divide your values. So I'm going to take the human body, because it was listed first, so I'm going to take 7 times 10 to the 27th power, make sure to put that in parentheses, and divide it by 7.5 times 10 to the 18th power. Make sure you put that in parentheses. Go ahead and plug that in your calculator if you have not already done so. And when you divide those, you should get roughly 9.3 times 10 to the 8th power. Let's say, for example, though, they wanted you to find it in standard notation. You would just make sure to go to your norm mode and type in that value. And you would get 933,333,333.3. So just a few things to clarify when you're doing these types of problems. Read the question. You're able to use a calculator, so you have to see, are you adding, subtracting, multiplying, and dividing? Make sure you are in the correct mode. Should you be in norm mode or scientific mode, depending on what the question's asking you to do. And as always, ask your teacher for help if you need it. Now, since you're done with the video, you can move on to the review for the test. Also, if you wanted to watch a little bit of video dealing with powers of 10, what I have here, you could just search it on YouTube. It's called Powers of 10, and I guess it was made in 1977. It just shows you more ways whenever you are dealing with magnitude and increasing or decreasing, dealing with powers of 10, just to get you thinking about how large or how small certain things are in this world.